Another thing that is very helpful to notice and use when looking at graphs, equations, and tables is something called rate of change. Rate of change is the comparison of how one amount changes as a consequence of another amount changing. When we're looking at tables, it's helpful for calculating the rate of change. And we're going to look at using a table to help us calculate the rate of change. There is a formula for calculating the rate of change, and we'll use the formula a little bit later. But right now, we're just going to use a table. And the rate of change is the change in y over the change in x. This little triangle is the Greek symbol delta, which represents the word change. And so we're going to do the change in y divided by the change in x. So we've got a couple examples we're going to look at. The first one says, suppose you are driving. You notice that after driving for 2 hours, you are 115 miles from Seattle. You continue driving and calculate that after driving 6 hours, you are 315 miles from Seattle. What is your rate of change? The first thing you might want to do, especially because we're going to be finding the rate of change using a table, is create a table. So I'm going to create a table using x and y coordinates, and it might be helpful to determine what your x and y values are. One rule of thumb or hint is that when dealing and trying to figure out what your x and y values should be, one hint is that time is always your x value. Anytime you're dealing with time, time is always the x value. In your situation, you might not be dealing with time as one of your components, but if you are, that's going to be helpful for you because time is always your x value. So we're going to have an x of 2 and an x of 6 because we have 2 and we have 6. And at 2 hours, you are 215 miles from Seattle. So at 2, I'm going to, and I said 215, I meant 115. So at 2, I'm going to write 115 right next to it because at 2 hours, our input is 2 and our output will be 115. And when our input is 6, our output will be 315. So we have 2 pieces of data. We have our starting point of data that we noticed, and then we have our second notice of data later on when we were driving. And we want to determine our rate of change using the rate of change formula, or I guess this isn't technically a formula, but we'll call it a formula for now. So a rate of change is the change in y over the change in x. And change just means difference. How much is it changing? What is the difference between those numbers? So if we think about the change in y, that's these numbers. What is the difference between these two numbers? So to find their difference, we just want to subtract them. And how you subtract them is up to you. Just keep in mind, if we are going to take the bigger number here first, then this number needs to be first in our subtraction for the x value. So I'm going to stick with the bigger number that I'm going to subtract. So I'm going to take the 315 and subtract the 115. And I'm going to make note of that here, that I'm subtracting, I'm using the second value point in the front and the first value point here. So that when I find the change of y, or sorry, the change in x, I'm going to put that here. Some people, I meant to use my lasso. Some people like to go ahead and use or find their change right here in their table without even coming and doing this part over here. Some people like to just do it in their table here, which you're welcome to do as well. You can just go ahead and subtract directly in your table here and find that difference. To go from 115 to 315, you have to add 200. And to go from 2 to 6, you have to add 4. And that's essentially what's going to happen here is you're going to, when you subtract these, you're going to get that same information. When I subtract these two numbers, I'm going to get 200, which was my change in y. And then when I subtract 6 minus 2, I'm going to get 4, which is my change in x. And then I want to divide that. 200 divided by 4 is 50. Now, when you are looking for your rate of change in a word problem like this, in a context situation, you do want to have units, and your units are going to be using the units from the original problem. And in this case, it's miles per hour. And you get your units from your vertical unit divided by your horizontal unit. So your y variable divided by your x variable. That's essentially what you're using here, your y divided by your x. So your y divided by your x. Let's look at another problem here. And then we have one more concept for this section that we will look at. So this is, once again, another rate of change problem. This table gives population estimates from Portland, Oregon, from 1990 through 2014. It says to find the rate of change in Portland population in 1997 and 2000, as well as the rate of change between 1990 and 95. So this is two different sets of problems. So let's start with 97 and 2000. Let's highlight those purple. Do 97, 2000. And I will number those 1 and 2. And we want to look at the, I don't know why I keep writing the letter A for that. The change in y over the change in x. So how much does the y change versus how much does the x change? And it looks like the population from 97 to 2000 is going up. So it's being added. You have a number that's from here to here is going up. And to figure out how much is going up, you can just subtract these two numbers. And then from 1993 to 2000, that's 3 years. And we got that from subtracting as well. And to figure out the exact or the estimated rate of change, we're going to divide that out. And when we divide that, we're going to get a decimal. And I went ahead and rounded my answer because when we think about the context of this problem, you can't have a fraction of a person. And for me, it didn't make sense or feel right to put a fraction of a person for a set of data like this when we're talking about population. And maybe in the real world, they do still do that. But for me, I don't want to think about a portion of a person. And so I rounded to the nearest person. And we are going to put the units because we're talking about in context. And this is people per year. And so that is the average rate of change of people per year given the population estimate in the table for the 1997 to 2000. And the second one is looking for 99, or not 99, 1990 to 95. Those are on the same side of the table here. So I could actually kind of look at my table, or I could actually like create my, do my little change of X, change of Y on the sides over here next to the table. So we're doing the change of Y, change of X. I've already done the change of X. It went up by 5, which I got that by subtracting 95 and 90 to give me 5 years of change. And to get this change, looks like the number, it went from 98 to 90, I'm sorry, from 48 to 49. So that number's going up. So it's positive, it's going up. And I can get that difference from subtracting these two numbers. And when I subtract them, I get 10,547. And when I divide that up, once again, you get a fraction with the decimal. And I rounded that to 2,109 people per year. And I keep running out of space. One day I will learn how to estimate how much to write when writing digitally.